Hi everyone, in today's lesson we're going to go over applications of exponential/log equations. And we're going to do that through word problems. So the first type of word problems that we're going to talk about today is an annual compounding or an annual exponential equation where it's growing exponentially or decreasing exponentially over time. So let's look at example number one. It says Miss Ampini bought a 2015 Honda CRV for $30,000. It is known that the car has a depreciation or the decline in value rate of 20%. The value of the car at any time can be determined by the formula V equals C, 1 minus R to the T, where V is the value of the car after T years, C is the original cost, and R is the rate of depreciation. So part A is asking, after 3 years, how much is the car worth? So because we're talking about an annual depreciation, this keyword here, depreciation, means that we're going to use this annual compounding formula, which we have up here. A equals P, 1 plus or minus R to the T. And we choose to use either the plus or the minus, depending on if the situation requires money or an item to grow or if the money is decreasing. So in this formula, P will always be your initial amount, initial meaning your starting value. A will always be your ending amount. R will be your interest rate expressed as a decimal, and T will be your time in years. So if you notice the equation that I gave you and the equation that the formula or word problem rather is giving us is the same thing. It's just they're using different letters. So let's use the letters that we have. So we have A equals P, 1 minus R to the T power. A is my ending amount, P is my initial, R is my rate, and T is my time. So I'm starting off with $30,000. So that goes into my initial or starting amount. That goes in for P. So I'm going to put 30,000 in here. And I want to know how much the car will be worth at the end of 3 years. So what will the ending value be? That's your A. So we're going to leave A here. What will the ending value be after 3 years? T is time, so we'll put 3 up top for years. And the rate, 1 minus, well, my rate says that the car will depreciate by 20% each year. So what do I mean by changing a percent to a decimal? Well, the number 20 would end there, and I would put 2 decimal places to the left, and I get 0.20. So to get the answer, all you're going to do is type this into the calculator just the way you see it with parentheses and everything, and you should get your answer. Now notice the directions are saying to round to the nearest cent. So that means you're going to round to 2 decimal places. So take a minute, type this into the calculator just the way you see it, pause the video, and hit resume when you're ready for the answer. Okay, so you should have gotten a nice whole number here. So after 3 years, the car should be worth $15,360.00. Since it says round to the nearest cent, you really should go those 2 decimal places. So this would be your final answer. Now, that should make sense, right? Because your number that you got is less than the amount you started with, right? We started with a $30,000 car, and after 3 years with this large depreciation rate, it's nearly only worth half of what you paid for it, right? They always say a car is the worst investment because, it loses value the second you drive it off the lot. Okay, so that's an example of using the exponential decay formula using the minus. Now we're going to do parts B and C another day. In order to figure out how old the car is, we're going to have to use logs. So we'll do that another day. For now, let's just focus on this example. All right, let's move on to example number 2. So now we're here talking about compounding interest. So now we're talking about a money example. We're talking that Nick invests $1,000 at Chase Bank, offering 2% interest rate. Part A is asking how much money will Nick have in his account after 3 years if he makes no additional deposits or withdrawals. Now, in this example, I need to tell you how many times per year his money is being compounded. So this word compounded is just a fancy way for saying how many times a year does the bank give Nick interest. So in this problem, I should have told you. So I'm going to say he will have his, how much money will he have in his account after 3 years if he makes no additional deposits or withdrawals if the interest is compounded, let's say monthly. Okay, so what that means is every single month, the bank is going to do a calculation and they're going to give him interest. So we have the same formula as before, except I have this new piece with this n, where n is the number of times I'm compounding per year. So if in this example I'm telling you that we're compounding your interest monthly, that means every single month I'm giving you interest. And since there are 12 months in a year, the number of times it would compound per year would be 12. So in the formula, we're starting with Nick's initial investment. P is always your starting amount or your initial investment. So since Nick is starting with $1,000, we're going to put that in for P. 1 plus, now his interest rate this time is 2%. So remember to take 2% and change it to a decimal. We move the decimal 2 places to the left and fill in the 0. So that would be 0.02. N this time is 12 because I am compounding the money monthly. That means there are 12 months in a year, therefore he gets interest 12 times. And then N is 12 on top, and T is 3. So 12 times 3 goes on top there. So take a minute, type this into the calculator just the way you see it. Make sure you're using the alpha y equals button to get the fraction. Pause the video and hit resume when you're ready for the answer. Okay, now this example didn't specifically say what to round to, so let's round to the nearest cent since we're talking about money. So I got 1,061.78 cents. Now, if you did not get this number, that's okay. We'll talk about it in class about how the calculator should be used, but you really should be checking to see if you did or did not. And again, we'll do parts B and C later on because we're talking about finding time, how many years, and therefore we'd have to use logs to solve it. Just another couple of notes here. Instead of changing, I could tell you that instead of getting monthly compounding interest, you could get quarterly interest. And think of the 4 quarters that you have for marking periods. Quarterly interest would mean 4 times a year. You could have semi-annual interest. And semi-annual means twice a year. Semi meaning half, right? So 2 times a year. And then you also could get your compounding daily. And daily would mean 365. So this word problem could change depending on the word that's given, quarterly, semi-annually, daily, or even monthly in this case, okay? All right, last example would be compounding continuously. So here we have an example. We're talking about Susie investing $2,000 in an account that is compounded continuously. So compounding continuously is actually the best type of compounding. It's better than daily. So if you're getting daily compound, that means you're getting interest every day. So 365 days a year. Continuously is a little bit more than daily. It's pretty much, I can't exactly explain if it's every minute, but it's more than 365 days a year. So there's a different formula for that. Whenever we see compound continuously, we want to use this formula. Now, let's write it down first and plug in what we know. So A equals P, e to the RT power. Now, E is just a number, kind of like pi. So you can find E in the calculator if you hit second divide. So if you hit second and then you hit the divide button, you'll get E. And then you can hit enter if you'd like to see what it is. It's a number. It's 2.718281828, and then it kind of stops from there, but it's similar to pi. It's an irrational number that we're going to use in this formula. So we're talking about Susie investing beginning with $2,000. That's my P. That's my start value. So we're going to put that in for P. So 2000E, the number on the calculator, at an annual interest rate of 1.5%. So remember, we take the decimal and we move it two places to the left, fill in any gaps. So my interest rate is 0.015 rather. And they want to know how much money will Susie have in her account after 3 years. So again, my time is 3. So to figure out how much money she'll have in 3 years, all you're going to do is plug this into the calculator just the way you see it. And again, make sure when you have the E, you're hitting second divide to get to it. All right, so take a couple minutes, pause the video, type this in, and hit resume when you're ready for the answer. All right, so you should have gotten $2,092.06. And that's how much money she would get if she was compounded annually. Okay. And then again, tomorrow and the next day, we'll go over parts B and C because they're asking to find how many years. So just a quick little recap if you want to write down some information. We have a formula that we use if we have annual compounding. And this one's also used for like depreciation as well. A equals P, 1 plus or minus R to the T power. Then we have other types of compounds. So if N was, say, semi-annual, that would be 2. N would be quarterly, would be 4. Monthly would be 12. And 365 would be daily. So we would use those formulas, or we would use, this formula for those types of compounds. So that's category 1, category 2, and then the third category is if I talk to you about something compounding continuously, we use the formula A equals PE to the RT. Best way to remember that one would be PERT. A equals PE to the RT. So these are the three formulas that we're going to use and focus our attention on tomorrow. Under the annual compounding, you could also write also for depreciation. Any types of annual depreciation would work there as well. All right. So yeah, that's it for today. If you have any questions, now's a good time to jot them down and ask us in class tomorrow. Okay. Have a good night.